So this is the second video on expanding and simplifying. So I've already shown you how the three different methods work to expand and simplify binomials like this. And now I'm just going to go over two more examples that you'll see. So this one has a negative in it that we didn't see yet. And this one looks a little bit different, but it's exactly the same process. So these ones are going to go a little bit quicker, and I'll just explain as I go. So let's 2x plus 4 and x minus 3. Let's look at that. 2x plus 4 and x minus 3. There we go. So 2x would look like this. There's two x's, and then plus 4. And then x minus 3 would look like x and then minus 3. So those are negative ones. So just like before, we're going to line them up like this and start filling in the blanks by multiplying these things together. Oops, I only have 3 here. 1, 2, 3, 4. So I have 2 x's here plus 4. So this is 2x plus 4. And this one is x minus 3. And like I said in the last video, it doesn't matter which one you put on the top and which one you put on the side. They're both equivalent to each other. So then we need to start filling these in. X times x is x squared. X times x is x squared. So x times 2x is 2x squared. We have two of these big blue ones. X times 1 is x. So x times 4 would be 4x. We have 4 of these green ones. And then over here, we have negative 3 times x, or just specifically in this space, we'd have x times negative 1. So x times negative 1 is going to be a negative x instead of a positive 1. So then we do x times negative 3, and we get negative 3x. But if we have 2x times negative 3, we get negative 6x. So there are 6 of these over here. And then we just need to fill in this last space to make our rectangle. And we have positive times a negative. So remember, we talked about this in class just yesterday. Positive times a negative is a negative. So all of these ones will end up negative. And there will be 3 across and 4 down. 3 times 4 is 12. I'm going to have to fill in some and flip them because, again, we've run out of them. I hope there's enough. No, there definitely aren't. So I'm going to steal some from up here because we already know what goes there. So we had our x minus 3, and we had our 2x plus 4. And when we multiply them out, we get 2x squared. And then the key thing here is, remember in that first video, I said that if you have a positive one of these and a negative one of these that are the same size and the same variable, same size and same shape here, they cancel out. So I have 2x squared, and then here I have 4 x's, but each one is going to cancel out with one of these negative x's. So there's 3 that are canceled and 4 that are canceled, but I still have 2 left. So I have 2 negative x's. So 2 negative x's, so negative 2x. And then I have, minus 12. I forgot my number there. So the answer here, when we multiply 2x plus 4 times x minus 3, we get an answer of 2x squared minus 2x minus 12. So let's go look at the area model for this one. So I gotta remember now. Sorry, trying to use the wrong thing. There we go. So we ended up with an answer of 2x squared minus 2x minus 12, if I remember correctly. So we're going to check it with the other two methods and make sure we get the same answer every time. So we have 2x plus 4 times x minus 3. Make sure that negative here Stays with that 3 here. Very, very important. Then we multiply. 2x times x is 2x squared. X times 4 is 4x. Negative 3 times 2x would be negative 6x. And negative 3 times positive 4 would be negative 12. And remember, we get like terms here on the diagonal. So we get 2x squared. And then we have to collect the negative 6x and the positive 4. So if we start with negative 6 and we go up 4 in the positive direction, we're at negative 2x. And then we have negative 12. And we get the same answer both ways, which is good. And then our last method is using FOIL. So we have to multiply the first terms together. So 2x times x is 2x squared. Then we have to multiply the outside terms together. Negative 6x. Then we have to multiply the inside terms together. And finally, we multiply the last terms together. And you should notice these are exactly the same numbers we have here. And these are exactly the same things as we got when we had our algebra tiles. So we had 2x squareds, the big blue ones. We had negative 6x's, which were the red rectangles. We had positive 4x's, which were the green rectangles. And we had negative 12 ones, excuse me, which is those small red squares. So again, we collect our like terms. We get 2x squared minus 2x minus 12. So of course, we got the same answer every single way. This one, I'm going to skip the algebra tiles just so it doesn't take forever to draw them and make them again. But the same method would work. And if you like using the algebra tiles, then please go ahead and do so. For now, like I said, I'm just going to show you the other methods here. So remember that anytime you have an exponent 2, it means that the thing underneath that exponent, so if we had like an x squared, the x would be multiplied by itself. Or if we had 5 squared, the 5 is multiplied by itself. Here, the exponent is acting on this entire bracket. So what this means is that we have 2x plus 3 times itself. So we have 2x plus 3 times 2x plus 3. So this is just like the last questions we've just been doing. So we have 2x plus 3, and we have 2x plus 3, and then we multiply them out. And again, like I said, you can do this with the algebra tiles as well. So we get 4x squared plus 6x, 6x, and 9. So when we put this together, we get 4x squared from here. And then we have 6x twice. So we have one of those 6x's and another 6x, which together would make 12x. And then we have that 9 here with no x's, so it's just a 9. So plus 9. If we use FOIL to do this, it's best if you write it out like this. And then you go multiply your first ones. So we get 4x squared. Multiply your outside ones, 6x. Multiply the inside ones, and then multiply the last ones. And then collect your like terms, 4x squared plus 12x plus 9. So again, we get the same answer no matter what method we use. Whichever method you are most comfortable with is absolutely good to use. You don't have to worry about knowing all three, but you do have to know how to use at least one of them.